Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today's topic of discussion is Newton's laws of motion. Newton has given three laws of motion, known as first law of motion, second law of motion, and third law of motion. Okay. Let's look at the first law. It says that if body is in a state of rest, it will remain in the state of rest. And if it is in the state of motion, it will remain moving in the same direction with the same speed unless an external force is applied on it. So what it says is, suppose there is a book kept on the table. It is on the rest. If it is in the rest, it will remain in the rest. You won't see the book moving in the night. It will remain on the table itself, right? So this is a state of rest. Similarly, if a body is moving on a frictionless surface with a constant speed u, and let us assume that the air resistance is also not there, or any kind of resistive force is not applicable on the body, then it will continue moving in the same direction with the same velocity u. Okay, so it will keep moving with the same velocity, same speed in the same direction without any change in the speed, right? So that is the state of uniform motion. Okay, both these are representation combiningly called inertia. That is inertia of rest or inertia of motion. The tendency of a body is that if it is in rest, it will remain in rest, it will not move. If it is in constant speed in a particular direction, and if there is no resistive force, it will continue moving with the same speed in the same direction, right? Then the third important thing in the first law is the external force. If this state of inertia has to be changed, that is, a body in rest need to move, then I need to apply an external force. Okay, if I push this book, it will move, right? Likewise, if this is moving with a constant speed in a particular direction, and if I push it backward, then its speed will start reducing. So if I apply an external force, then the state of rest or state of motion can be changed. So the concept of force is appearing in the first law of motion, and the purpose of or the effect of force is to change the state of motion of the body. If it is in rest, it will introduce motion into it. If it is in motion and you apply it opposite direction, it will reduce the speed. If you apply a force in the same direction, that will increase the speed, but there will be a change in the state of either rest or motion. Okay, so that is about first law. Let's talk about second law. Second law says that the rate of change of momentum of a body is directly proportional to the force applied on it. And the change in momentum takes place in the direction in which the force is applied. So first thing, it is talking about rate of change of momentum. Let's look at momentum. Suppose there is a body of mass m and it is moving with the speed u in this direction. Okay. Now, you applied a force F on this body, and eventually, because you applied a force, so its speed will increase, and this body eventually will attain a speed of v in the same direction. Okay. Now, momentum is defined as, it is denoted by P, and it is defined as mass into velocity of the body. Now, initially the body is moving with the speed of u in this direction. Momentum is a vector quantity. I'm not introducing a vector. I'm just explaining that in a simple way because the body is moving in x direction itself. So I'm just not introducing the notation of vector. Understand that the body is moving in the same x direction. Okay. Then the initial momentum will be equal to mass into u because initial velocity is u. Final momentum, because it has attained the speed v, so it will be m into v. So what will be the change in momentum? Change in momentum is delta p, that is p final minus p initial, that is what is change. Okay, so that will be equal to m times v minus m times u, that is initial momentum and this is final momentum. So this can be written as m times v minus u, and that can be written as m times delta v, that is change in momentum is equal to mass into change in speed, okay, in the same direction. Okay, now let's look at it again. It says rate of change of momentum. Change of momentum we got, rate of change of momentum. Suppose it took delta t time in changing its speed from u to v. Then rate of change of momentum is delta p upon delta t. In this much time, the momentum changed this much. It changed by delta p. So this can be written as m times delta v divided by delta t. Now this can also be written as m times delta v divided by delta t because mass of the body is constant. Okay, and therefore this can be written as mass into acceleration because change of velocity with respect to time is acceleration. Okay, so rate of change of momentum is acceleration. Now the second law says that the rate of change of momentum of a body is directly proportional to the force applied on it. So if you are applying force F on it, it is directly proportional to the rate of change of momentum, that is delta P upon delta T. So from proportionality to equality, I can change it by writing K times delta P upon delta T. Okay, where K is a constant, and then I can write that this is K times, because rate of change of momentum is equal to mass into acceleration, right? So I can write from here, because the rate of change of moment is mass into acceleration, so I can write this as mass into acceleration. Now unit of force is chosen in such a way that if at 1 kg of mass, 1 meter per second square, 1 meter per second square of acceleration is produced, it means 1 Newton of force is being applied. Okay, so then you can see that this 1 will be equal to K times 1 times 1, and therefore K will become equal to 1. Okay, and then you can write that F will be equal to mass into acceleration. So this equation F equal to ma, that becomes the mathematical form of second law of Newton. And this equation is always used when you are working on solving problem. Okay. Now it also says that the change in momentum takes place in the direction in which the force is applied, which you can notice here that when you are applying a force, the body's speed is changing from u to v, but in the same direction. This is the direction in which force is applied, and the change of speed is also happening in the same direction. Okay, because momentum is also a vector quantity, force is also a vector quantity. From this also you can infer that the force applied in a particular direction, that is in x direction, the acceleration will also happen in x direction, because mass is not a vector quantity, it is a scalar quantity. Okay. Now let's look at third law of motion. Okay. Third law of motion is most enigmatic and most confusing law. Many people remain confused about it. So let's look at it carefully. Okay. What third law says is that to every action there is always an equal and opposite reaction. Let's look at this. Suppose there is a book on the table and its mass is m. I applied a force, okay, on this. Okay. So from Newton's third law of motion, there will be a force applied on this book, and because there is a force applied, so there will be a reaction also, equal and opposite, right? So F will be appearing in the opposite direction also, right? Now, if I take this direction as a positive direction, right, then the net force on this body of mass m, or the book of mass m, will be what? F in the positive direction, so I am taking this as plus F, and this F in the negative direction, so I am taking it as minus F. So what is the resultant force on this? 0. So if there is a 0 resultant force on this, will the body move? Of course not, because there is no force to change its state of motion. From the first law also, because it is in rest and resultant force is not there, external force, resultant force is not there, so it should not move. But that is contrary to our observation. If I apply a force, the body will move from state of rest to some speed, right? It does move. If I push a book, it will move, right? So it means there is some problem in interpreting the Newton's third law of motion this way. Okay. Let's look at what is the problem. Okay. Newton's third law of motion says for every action there is equal and opposite reaction. But these two happen on two different bodies, not on the same body. So, if I apply a force on this book and I am the human, so that this book will apply a force on me, not on itself. You need to be very clear that action-reaction pairs are on two different bodies. Action is done by human on this body, so reaction will be done by this body on the human, not on itself. Now you look at this body. On this body or book of mass m, what is the force being applied? Only F. So the resultant force on this body is F, net force, in positive x direction. That will be equal to mass into acceleration from second law of motion. So acceleration produced in this book will be equal to the force applied divided by the mass, and that is how it will start from the state of rest and will go into motion, and its speed will increase. Okay, so as long as you are very clear that action and reaction happens on two different bodies, you will not land up in that situation that the resultant force is becoming zero. Action is happening by the human on this body. The body is putting reaction force on this human, not on itself. Okay, and that is how you analyze any resultant force on a body and then the acceleration on the body. Right? By this example and the explanation, you would have clearly understood all three laws of motion. In next example, I'll take one numerical example and explain the application of these laws. Thank you.